Usingizi Mrowan. Hey.
Hey.
Ona Lizia watoto wake nitoke huko kwanza.
Good morning. I think we can start. can start our lesson because of time. Time is not on our side. So before we go deeper, I would like us to know what language, what language does a computer understand? So we know that a computer is an electronic device that takes in data, processes the data, and gives out the output. And then before we go that, we realize that a computer is a digital device. What does it mean when you say that a computer is a digital device? We have this terminology called digital device. Maybe through the charts, when you say that a computer is a digital device, what does it mean? A computer is a digital device. What does it mean? Maybe through the charts. So Collins Wasike is saying that it uses binary digits. It means computations based on binary digits. Use binary digits in the various combinations. That's from Taylor's Mill. So we have come that we realize that computer usually understand what's called bits. A computer understands bits, and bits we have zeros and ones. That's the only language that a computer understands. So whatever we type to the computer, whenever we communicate to the computer, it means when you use human language, we call it high level language. It means that a computer needs to translate. A computer needs to translate to low level, low level, or we call it machine codes. Call it machine code for the computer to understand by the use of an interpreter. So we have an interpreter. An interpreter is just a software that translates high-level language. High-level language is a human language Like the way I'm typing on the screen, I'm using a high-level language. Then for the computer to process this information, it needs to translate this language into a low-level language by use of an interpreter or a translator, depending on the input, right? So that's how computer works. So computer only understand binary digits. Computer usually understand binary digits, as most of you have said. These binary digits is what now we call them as B by for binary. Then digits, we have TS, right? So whenever you hear someone saying about bits, bit stands for binary, B for binary, then TS for bits. So here we have binary, we just highlight. Then you have TS for bits. So the word bits comes from the word binary digits, because the binary, it means 2. Binary means 2. Binary means 2. So it means that a computer only understands zeros and ones, which are called binary digits. Binary, it means we have only zeros and one. So it means wherever we type in a computer, what we feed in a computer needs to translate that high-level language or human language into low-level language called machine code or machine language by the use of an interpreter or a translator. That's how computers operate. That's how computer operates. So to begin with that, let us go through this terminology. So we have bits. That's the lowest size storage that a computer understands. Then from bits we have bytes. Then from bytes, you hear that having kilobytes. Then from kilobytes we have megabytes. Then from megabytes we have gigabytes. Then from gigabytes, maybe we can go out to terabytes, right? So a kilobytes download file, the file has what's called KBs. Then MBs. Megabytes, some of you say that you are purchasing MBs. Gigabytes, you say that you are purchasing GBs, right? Then terabyte, you're purchasing TB. So I want you to know how many bytes makes 1 byte. Maybe through the chat, how many bits make 1 byte? How many bytes make 1 KB? How many KB makes 1 MB? How many MBs make 1 GB? How many GBs makes 1 TB? So through the chat, try to to calculate how many bits makes 1 byte. How many bytes make 1 KB? How many KB makes 1 MB? How many MB makes 1 GB? And how many GB makes 1 TB? As we progress,
Hey, wewe.
one bit, 80 bits make 1 byte. That's right. 1024 bytes make 1 kilobyte. That's right. 1024 KB makes 1 MB. Yeah. So when you buy one GB of data, when you purchase 1 GB of data, how many MBs will you be given when you purchase 1 GB of data? How many MBs will you be given? So like when I purchase one GB, I'm always given 1024 MBs of data bundle, right? So it's not 1,000. If you purchase and then they give you 1,000, just know that they have stolen from you. You're supposed to be given 1024 MBs to be one GB. Yeah, most of you are getting it right. Most of you are getting it right. Yeah, so we can continue from there. I think now you understand how the computer operates. So we can start with some various definition when it comes to computer programming. And maybe for us to understand computer programming well, we need to go and have a look at computer generation. Let us go have a look at computer generation. So we can start with our first generation of computers. And it uses, I don't know which language the computer use, because I understand it used to use switches. It turns on and off. Turns on and off. That's first generation computers that uses vacuum tubes, right? And it used to have switches, very big switches. And for it to process data, we used to turn these switches on and off. And the input, they used punched card. And this punched card had some holes on it so that the computer can read and understand this language. So it means this computer usually use it used ones, that is ones. And zeros. It used ones and zeros because it had mechanical switches that these switches were to be turned on and off for a computer to understand. So it means that a first generation computer use machine language. Machine language, in other terms, is usually called computer or low-level language, because the actual language that the computer understands. So it means that the first generation computers, it only relied on machine languages, zeros and ones, because when you have a look at how these first generation computers operate, you see it had some switches. It had some switches that the operator was supposed to turn these switches on and off for the vacuum tubes to operate. Then let us move to our second generation languages, and so that we understand what was the second generation language. So we realized that first generation computers were very hard to operate because they use zeros and ones, and this makes them to be mechanically difficult to operate. So it led to the advancement of the languages that they were using. So instead, it used symbols. The second generation computers use symbols or symbolic names. Use symbolic names, or we usually say they use what's called mnemonics. Mnemonics, something that's just the same as language, but not a real language. And these symbolic names, usually call them, the second generation usually use what's called assembly language. So, for example, in the first generation, you could take 1 + 1, right? That is a machine language. But when it comes to assembly language, you say 1, add 1. So it uses some symbols to represent how the computer use. So it uses called assembly language. Then when it comes to third generation language, So there was improvement in the language, and this language was much of human readable language, human readable language. So it used what's called numbers, and what's called high-level language, high-level language. And we say that high-level languages are human understandable languages, and that's how computer use. So it means that when you write an assembly language, a computer needs to translate this language into machine language. If you use a human or high-level language, it means that a computer used to interpret this language again to machine language. So we can say that a computer only understands, or we can say that it operates with machine language. So it means that when you feed a computer with the assembly language, a computer needs to translate, or the computer needs to interpret that language so that it can process that language. So that's why we have a compiler. So a compiler translates or rather converts. A compiler translates or converts entire program. If you write a program, programmers into machine language. And this machine language usually call it as object code. And what is an object code? What's an object code? When you write a program for a computer to translate. So an object code is a program code that when maybe computer programmers usually write when they want a computer to operate something. Then we have what's called a translator. Translator. This is a processor. A translator is just a processor that converts source code into object code. And what's a source code? What's a source code now? What's a source code? A source code is the original text that you program a computer to do. This original text used by a programmer. Write computer program. Hope you are making these notes are very important. In the exams, they will ask you to differentiate between a source code and an object code. Differentiate between a source code and an object code. So we have defined what a compiler is. have defined what object code is. Have defined what a translator is. We have defined what a source code is. Then we have what's called, we mentioned something called a compiler. What's a compiler? This is a tool, or maybe let us use the word processor, that translates, or rather converts entire. I think we have defined what a compiler is. Yes, it's here. We have defined what a compiler is. Let us define what an assembler is. Remember, we mentioned somewhere assembly language. And assembler, we can say converts, translates, assembly language into machine language. And we say that a machine language is the same as what the computer understands. Then we have what's called an interpreter. What's an interpreter? An interpreter converts, translates, set instructions. Instructions, we have said these are source codes. One at a time. So you can refer to the difference between an interpreter and a compiler. You realize that a compiler does everything at a go, right? A compiler does everything at a go, but an interpreter converts one instruction. So you can be having a program and you want the computer to interpret that program. So a translator will do everything at once, while an interpreter will do one instruction. That's how we can be able to understand that. So we have realized that computer usually understands binary numbers. So binary number, this is what we call them as codes. We call them as let us call them as machine code. So whatever we write a computer usually translates this information into bits, and that's what only the CPU understands. So if you have many bits, they form a byte, as we said. Then you have a kilobyte, a megabyte, gigabytes. Then you have we have terrible. So let us have a look what's called data representation. So how is data represented in a computer? How is data represented in a computer? So we have realized that data usually is stored and processed in binary form. Because this is the only way that a computer runs. So we have many number systems. That maybe we shall have a look at it. So we have the normal or human or high level number system, which call them as decimal numbers. Decimal numbers is these are counting numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So even if you have 20 or 23, at least you realize that you have a 2, we have a 2 and a 3. Even if you have 9, 7, 6, you see inside these numbers we have 9, 7, 6, so they repeat. So we have those decimal numbers that we usually use. Then a computer has what's called binary numbers. And it says the binary numbers is 0 and 1, 0 and 1. That's what a computer understands. Apart from that, we have octal numbers. We have octal. So we have octal numbers. So decimal numbers, we usually call them, because there are 10, we call them as base 10. Base 10 numbers. So binary numbers, because there are 2, we call them as base 2, right? Then we have octal numbers. Octal, what does octal mean? 10. Octal is 8, huh? Yes, 8. Octal is 8.
Yes.
Octal is 8.
Yes.
That is 0, 1, 2, 3, 4, 5, 6, 7. So those are 8 numbers. Then from there, other numbers are usually represented as A, B, C. Continue. We shall maybe have a look at this next week. Then we have hexadecimal. Hexadecimal. hexadecimal numbers. So this one are called as
Is 10.
these are called as base 8. Is 8. Then hexadecimal numbers
Is 10.
and 16 we call it as base 16. So I'm just introducing this concept so that next week we know how to convert. So I've mentioned about decimal numbers.
How many things?
I've mentioned about binary numbers. Mentioned about octal numbers. I've mentioned about hexadecimal numbers. So to the next week shall be a continuation of here. Right. Then we are supposed to have a look at data communication. And computer networks. So maybe from your perspective, what is data communication and what is computer networks? So from your side, what is data communication and what is computer networks?
Network is an interconnection of computers that can communicate. That is computer network.
Data communication, data networks. And how by the way, yeah, data network. Many computer. By using an example.
When are we going home, teacher?
Mute and mute. Mute.
Data communication.
No class. Utakaje next week.
Computer.
Yes, yeah.
Itu misalnya sih tengok tanya.
Computer network is the connection of computers on a system for transmitting and sharing information.
Sasa iko hivi. Sasa kama naongea hivi
The connection of computers on a system for sharing and transmitting information.
Anang'anyang'any.
Oke mwepesi.
Kuna dead.
Oke mwepesi lele.
Mi ng'weny.
Wangu na tane na ngire ngam.
Ne.
Wangu na tane ngomuru. Pes.
Aniala.
Keep the chats coming. Keep the chats coming.
Ini kasi na. Wangu ya.
What's computer network?
Uli.
What's computer network?
Dewo ya idano na. Tu. Oke la.
Goma the text. Yeah.
Apa kita tanya? Karena manusia meminta kita yang.
Kendane. Anilongit.
Kalau saja warna tanda.
Ini rara.
Sudah.
Yeah.
Pas ada kan.
So we can have a look at those questions and respond to them.
Ala pas ada kan.
Ara kata aja kok karo even media. Karo. Ara kata kok dulu. Omoni.
Kita kalau sentalano kau nggak tanya, talangnya kata kata setahun.
Tinggal lah. Subuh itu. Kamu agak napa dia? Kata aja kok sangka. Kok.
Ini yang jago sana.
Ini. Itu nak. Sama aja kan. Itu nak. Aja yang itu.
Mana? Where to? Where? Mana? Amo tu gua. Loh baguti.
Pero no. Dime. Itu pun valia. Kalau mau tuh bro tuh jual putih. Kayaknya lumina.
Wait boys.
Uga.
Wait baguti. Halal.
Ya kita aja.
Oli ang gitu go. Agi jam mage. Jam mage. Ini Jojo. Enggak. Wah, itu kuane gonge bagele ni.
Kwa mau mereka tu dia neng tapi. Ana kok aja aing yo kiri bisi buan.
Dari bisi tenyo ngorojai.
No ngino los telia.
Ana apa ne bulu jaga.
Ajuda ke kwemambe.
So we can Senegal Nyamaza. Senegal, keep quiet. So we can start with the computer data communication by having a look at components. Now this comes from communication skills. Components of data communication. So maybe for computers to communicate, what is it required? What are the requirements? What are some of the setup that needs to exist before computers? So what are some of the components of communication? Or let me reframe, what are the components of communication?
Wakaniomba 100.
So first of all, we need to have a channel, or maybe we can start with the sender, right? We need to have a receiver. We need to have the channel. This channel we usually call it as the media. Or if it's once a medium, if it's more, we call it as media. Then apart from that, we need to have the message, or we call it as data, right? Then we need to have feedback. And then also we need to have what's called protocol. A protocol. So these are the basic components of data communication. These are the basic components of data communication. So a sender is a computer that is sending. A sender is the computer that is sending the message. A receiver is the computer that is receiving the message. Then these computers are communicating through a channel, a medium, a media if there are many. Then also we have the message, this is the data, and we say these are zeros and ones that the computer is sending. Then we have protocol. So what's a protocol? A protocol, these are rules. These are rules and standards. These are rules and standards that computer use to communicate. So let us start with the channel. Let us start with channel or media. The channel or media, this is the path. The channel or media, this is the path. Through which is the path through which data is sent over a network. And we have two channels. We have two types of channels that the computer can communicate. We have a wired channel and then we have wireless channels. So maybe also through the chat, can we mention some types of wired channels that computer usually communicates, and also come across what are some types of wired channels that computer communicate? Maybe through the chat. Through the chat, can you let us respond?
Copy pia. Huyu ameweka cable by the cable fiber. Naanza kuikumbuka. Nimeona tu hapa cyber. Cyber.
Cables.
No, twisted wire.
Ndio kama mbona dogo wenyewe.
Hapana. Mpaka ni optic fiber. Yeah. Mimi yenye najuanga ni fiber wire bana, alafu tuko na twisted, tuko na copper wire. Hizo bana, natosha hizo tatu. Alafu USB cable. By the way.
Mnyamaze bwana. Kwani?
We are on a business.
Angi kwana kipende uga.
Mano bwana, luego gane.
Có cả năm tệ. Có năm tờ có liền nữa. Mambo.
Ya aja rajin.
Oi. Kata style vậy.
Anh nói bài nào quá này.
Cha niona hata nijibu aje. Jibu chafu tena tunapelekana kwa bawani wewe.
Then give us example of wireless channels, examples of wireless channels or media. Examples of wireless channels or media. So we can have wireless, wired medium, coaxial cable. Do you know what a coaxial cable is? The cable that you use to connect your antenna to the TV. Some of you have mentioned about fiber optic cable. Some of you have mentioned about Ethernet cable. So Ethernet cable, we have those cables that when you go to the lab, the computer are connected to the internet through that Ethernet cable. And many more cables that comes into existence. So the most important cable is the fiber. What are the advantages of using fiber? Maybe someone can ask you. What are some of the advantages of fiber compared to these other cables?
Resistance.
Now we are in technology. What are the advantages of fiber cable?
What's the transfer of data? It's interesting.
Maybe they can ask you what are disadvantages. Fiber. Then we can go to wireless. Most of you have started with maybe Bluetooth. Some of you have mentioned about Wi-Fi. So Wi-Fi, what does Wi-Fi mean? Because Wi-Fi is an acronym. What does Wi-Fi mean? What does remote uses? When you want to control a TV, it's through wireless remote. So what does this boosters? You see these boosters of Safaricom. Which wireless technology does they use? Because it's also a wireless connection. So we have I want you to have a look at what's called microwave. Have a look what's called radio waves. Have a look what's called satellite. Right? So these are some of the technologies that come hand in hand when it comes to, and we have many more. We have many more of the technologies that we use when it comes to wireless technologies. One having radio wave, microwave, satellite. Let me have a look at the charts. This wireless fidelity. Good one. Yeah, I'm going through your charts. What other wireless technologies? Also, someone is trying to respond. Why use fiber? Why use fiber? So we can go and have a look at computer networks. Computer networks. Classification. How do we classify computer networks? we have realized we have wireless networks and maybe wireless networks. So computer can be classified according to geographical span or coverage. Geographical span or coverage. Have various categories when it comes to geographical span. Maybe through the charts, how can we classify network depends on the coverage, starting with the lowest to the highest. Maybe through the chart, how can we classify networks depending on the geographical span or coverage? Let us engage through the chart and see. Yeah, so we can classify computers network depending on geographical span. So by the smallest, we can start with the man. Don't know what man means. Then you have land. Or we can start with the pan. Let's start with the pan. Man. I don't know, we come with land first. Then we have man. Then you have one, right? So this is a personal area network. So this is a network that you can form in your room, isn't it? You can connect a Bluetooth to your computer. You can transfer files to your friend. So that's called a personal area network. Meziona. Sasa moja ya leo. Kani nataka uanze nayo. Angalia ya kwanza hiyo research methodology. Hiyo iko sangapi? Anza hiyo saa hii. Financial accounting. Hii ya pili hapa. Hapa kazi sasa. Wait, for serious. Then we have local area network. Have local area network. Then we have metropolitan area network. Then we have wide area. So as we have said, personal area network, this is a network that's very small. You can establish within a room. You can connect your phone to your neighbor's phone. You can connect your phone to the Bluetooth, or you can share a file through Zenda. So these are some of the small network that you can establish, and they are called personal area network. Then we have local area network. These are network that can cover a room. Like when you go to a computer lab, you go to a cyber, we have that small network that connects computer together so that they can share resources. Have a computer, maybe a network within the Kibabi University, isn't it? So this network that covers a building or covers an organization, and it can be accessed through that organization. We call it as a local area network. Example of local area networks like networks in a university, network in a building. So it's a network that covers a particular organization or a particular building. That's called a local area network. Then we have metropolitan area network. So as the word metropole means a network that can cover a town. Yeah, it can cover a town. So you can have a network. Let us assume you have a network at Kibabi University. Then you have a network at maybe Kibabi University town campus. It covers a town, so that maybe if you have branches, or we have organizations that have branches within a particular locality, call it a metropolitan area network. Then we have wide area network. A wide area network, this is a network that covers the entire world, or it can cover the entire world, or it can cover. So personal area network, we have said personal, stroke small in size. Then you have local area network. I'll say that this type of network can cover a room, it can cover a building, or maybe it can cover an organization. Like here in Kibabi University, you are all connected to Kibu 2.4, right? Or Kibu 2.5. 5.0. That's a local area network. Then you can have a network that can cover a town, a particular town, or a particular metropolitan. That's why I call a metropolitan area network. Then you have wide area network. This is a network that covers a country. Can covers a continent, continent or covers the entire world. Covers the entire world. That's called a wide area network. So wide area networks, you can access it from anywhere, right? If you are in Japan, you can access Kibabi University website. So it means that Kibabi University website is on a wide area network. And most of the wide area networks, you see that they start with www. So if you see a network that starts with www, it's called a World Wide Web. World Wide Web means that you can be accessed anywhere within the world. So those are categories of computer networks according to the geographical span. Also, computer networks can be classified according to topology. Computer network topology. So what is a topology? What is a topology? What is a topology? Maybe through the charts. What's a topology? What's a topology? What is a topology? I know submit assessment. Click hapo juu. Sielewi system hii.
Uje alikuja bila kamera.
So let us have a look what is a topology. Someone said that it's a branch of mathematics that deals with property of space. Hey, Celeston Davis. Mathematicians, leave mathematics aside. Let us forget about mathematics. Forget about mathematics. Forget about mathematics. So let me share a screen. Let me share a screen. Yeah, here it is. So a computer topology is the way is the way various components of a network. This is how computers are connected. And remember, computers are usually connected through a switch, a router, or a modem, right? So the way these computers are connected, they usually form a pattern, and that pattern that are usually created is called a topology. So network topology defines the layout or the virtual space or structure of a network, not only physical, but we have some logical arrangements. So the way in which different systems or different computers are organized, are connected, or communicated with each other is usually determined as the topology of the network. So topology can be physical, how the computers are organized, or it can be in a logical form. This means physical topology is the physical layout. Is the physical layout of computers, the servers, workstation, and cables in the network. So when it comes to logical topology, this is the way information flows between different components of a network. So you have these 6 types of network topologies. You can note them down: half bus, star, ring, mesh, tree, hybrid. So can you note them down? And if possible, you can explain what's a bus topology. Yeah, if you start exam. Ring topology, mesh topology, tree topology, and hybrid topology. Click done once, tick done. Them they bend. Next, some instructions once. So through the chart, waliwaambia nitakana uchore mahali upige picha usikane. Uko na material ya kuchora. Chukua.
Ila si.
So let me go through the chat and see what you have posted. Shitera is saying that first, the bus topology, the connectivity is done using a single cable to connect various devices, right? Mary Wamalo needs 20 bob to buy bundles. Mesh topology involves various connections. Okay, let me mute everyone. Let me mute everyone. Okay. Okay, so I have to mute everyone. Sorry for that. Let us start with the bus topology. Nimesha kulog out kitambo kwa sababu umetoka kwa kamera. Hiyo vitabu tuchukua uziweke hapa. Jina nitakana uchore. So a bus topology, sorry for that. The computer are connected through a common communication media, as some of you have said. So we have a central wire that we use to connect as a communication media. This central wire is called the bus. So that's why I call it the bus. So we have a single media or a single cable that runs from one computer to another. Let us have a look like a tap of water. So if you connect a tap of water, you realize that we have some connections. Your neighbor connects on the same tap of water. The same pipe connects to the entire village. So when it comes to bus topology, that's how computers communicate to each other. Yeah, so that's how a bus topology works. And this is an example of a bus. So we have this one cable that runs through, and all other computers are connected to this bus to share the network or to share resources. Maybe let me ask, why do we need a computer network? What's the main objective of having a network? Or why do we connect computers together? Maybe from your point of view, why do we connect computers together? Why do we connect computers together? Why should we have a computer network? Let me have a look at the charts. Yes, and have been answered. Eshtera has said that we connect computers to share resources. So we have a bandwidth, that's the internet, isn't it? So we form a network so that we share the same network. We connect computer together so that we can share resources. These resources include internet connectivity. We can connect many computers using the same cable. We can connect many computers to the same printer, right? We can connect computers to one single server. So the main purpose of having internet or having computer network is to share resources. And these resources include the internet, include the channels, include the data, the internet, include some servers, printers. So we share also computers. Someone has said for multitasking, that's right. So we can have many computers that run the same application. Remember, we came across multiprocessing, multithreading, and multitasking and batch processing. So we share computers to synchronize coordination so that we process and save time and resources. That's the reason why we need a computer network. So advantages of this bus topology, we say that our bus topology is easy to install and configure. It is cheaper and can be easily extended. But when you have a look at this network, in case this computer network, in case this cable breaks here, you see these other computers on the far end will not be able to communicate. So it means that when you increase the number of computers on a bus, the speed, there will be a lot of traffic. It will reduce the performance. Also, the signals will be lost. So sometimes also it's also difficult to troubleshoot. So let us assume we have these 5 computers and this network breaks between the 3 and the 3. So it's very difficult to troubleshoot where the problem is coming from. Another topology we have star topology. So a star topology, as the name star means, it uses separate cables for each workstation. Okay, the cable connects the workstation to a central device, typically known as a hub. So a hub is like a switch that we connect all computers to the same so that we can share the media. So when it comes to star topology, the configuration provides a more reliable network that you can easily extend. With star topology, when one cable breaks, you can easily identify because one computer connects to that hub, unlike bus topology, where we connect each and every computer to the same cable. We see that in bus topology, when this computer breaks or when this computer loses the network, you can easily connect because we have this central hub. So it means that when maybe a media or a channels get broken, all these other computers can be easily communicate. Compared to bus topology, you see in bus topology, when one cable breaks, you see the connections will be lost. So it means that if there's a problem with the cable, only the station connected to that cable is affected. So for you to add another node, you just take that computer and plug it on the hub. So advantages of star compared to the bus topology, say you can easily expand the star compared to the bus topology. You can easily troubleshoot because if one cable here breaks, you can easily identify that one cable. Also, you can support multiple connections to that topology. Disadvantages of star is that if the hub fails, a hub is like a socket, it's like a switch. It's like a switch, right? So it requires many cables. You see, when you add a computer, it means that you need to add a cable. So if this central supplier of the internet fails, it means that the entire network will be down. So sometimes if the networks become extended, it means that the bandwidth will fail. So it means that you need to have something like a repeater, or you need to have something like an amplifier to amplify the signals if you want to extend the signals. Then we have a ring topology. As its name suggests, these arrangements forms a ring. Yeah, so every computer is connected to the next computer in a ring, and each transmit what is received from the previous computer. The messages flows around the ring in one direction. Some ring networks do ring token passing, so we can just know that the computers are connected around to form what's called a ring. Can you answer? Yeah, so that's how a ring topology works. So computers are connected one to the next, one to another one, so that they form a ring. Advantages of ring: provides an orderly network in which every device has access to the token. It performs well under heavy. Okay, pick up each other. Una login alafu pige picha hiyo swali. Fanya alafu submit. Sawa. Yeah, disadvantages of ring. It means that if one computer fails, the other ones will not be able to receive the signal, right? It's also difficult to troubleshoot a ring. So when you want to add a computer on this ring, it means you need to disconnect the ring, you add the computer, then you connect again. So it means when you add one computer or one node to this ring, you are this, or maybe you are making the computer not to be useful. Then we have what's called a mesh. As the word mesh wire, right? So a mesh network's mesh topology use separate cables to connect each device to every other device. So the keyword is that we connect each device to every other device on the network. So it provides a straight communication path for sending messages. Check the cable connected into two devices. A message sent directly from sender to the receiver because each one has individual and separate connection. So unlike hub, star, where a message needs to pass from one computer to another, or unlike ring, where a message needs to pass from one computer to another, a mesh, we need that a computer generally sends the message directly to the next receiver without going in loops from one computer to another. Advantages of mesh is that it provides redundant links so that a computer directly sends a message to the next computer, and it's also easy to troubleshoot. If computer A is not receiving signal from a computer 2, you can just know that the link that connects these computers has a problem. Disadvantages, you see, when you have 1,000 computers, forming a mesh topology will become a challenge. So it's expensive, difficult to install and maintain. Then you have tree topology. Like a tree, we have the stem, we have the roots, the stem, and the branches. Then you have some branches that form other branches. So we have the root node, which is now the supercomputer or the server or the server that serves these other computers. So this server is connected to one or more other nodes that are on one level lower in the hierarchy. So it means that the server controls how these other computers work and provide these computers with resources. So it's formed something like a tree. So we have the main server, connect to a super server, a sub server, then up to the last node. So it forms something like a tree, an inverted tree. So it means that it forms something like a hierarchy from the top, the middle to the lower levels. So it means that each nodes in the network have a specific fixed number of nodes connected to each at the next lower level in the hierarchy. So the number being referred is the branching factor, the hierarchical tree. So it forms something like a tree. Advantages of tree: you can scale, you can increase the network. It means you can expand. So it also offers a point-to-point connection of devices, and you can easily manage these computers because a computer is connected to a supercomputer higher above it. Disadvantages of it is that maintaining this network is very difficult. In fact, if you increase the branches and if you span or expand the network, maintaining it becomes very difficult. So it means if the server fails, the entire network comes down. Then you have hybrid. Hybrids are mixed. You can mix star with mesh. You can mix a ring with bus. So you can have two or more topologies that you mix together to form what's called a hybrid topology. So when you have two or more different computer topologies are connected together, it forms what's called a hybrid. Like in the picture below, you can have a bus, a star, a tree, a ring. They form what's called a hybrid computer. So that's what all about computer topologies. That's what computer topologies are. Some of you are saying that I'm so fast. And all this, what we have discussed are on the e-learning. So we have not discussed anything new. What we are discussing is on the e-learning. So you can as well get whatever I have discussed on the e-learning portal. So last week there was a cut that was going on. There's a cut that we are supposed to do just to realize how far you have covered the content. Most of you are able to do that cut, and maybe some of you did not do that cut. I don't know why, because I know I'm trying to look at the course outline. As well as whatever we have covered. So we have covered what's called data communication. Let me just have a look at that. Data communication. So maybe I can just revise. Let me just share this file so that we go together what we have covered. Yeah. So we have covered. So we have these questions. You are supposed to define what's a computer network, discuss various transmission media, to discuss the process of selecting a computer device and topology for various places. Then There's some questions that you are to answer in your own understanding. Define communication. What's a computer network? What's data communication? And we have also be able to discuss guided media. Guided media is wired. So another term from wired media. In exams, you can be able to differentiate. Guided is a type of media that's channel that has wire or maybe has some connections. So we have a twisted pair cable. We have mentioned about coaxial cable, and we have asked about fiber optic cable. So we mentioned about twisted pair cable, or we rather call it as Ethernet cable. So these are cable made up of copper wire inside that enables you to connect computers together. Also, we were able to discuss coaxial cable. Coaxial cable is that cable that connects the antenna. If you have ever come my own cable, you can connect area of TV. So we can as well use that to transmit data, especially in old telephony. So it has a so in the exams they can maybe they can draw you something like this. So you have an insulator, we have the metallic sheet, we have an insulator, then we have the cable inside. That's the coaxial cable. Then you have fiber optic. Also, I ask you the advantages of fiber. Okay. Then you have unguided. Unguided now is the wireless, right? So unguided is the wireless medium, and the components we have realized we have the center, the medium, the receiver. We have a decoder. A decoder is a device that changes the received signal to form what was before encoding. So at your free time, you should be able to understand what's a decoder and what is an encoder. So before a message is transmitted, it's usually encoded, transmitted, then decoded on the receiver, side. So internet, maybe someone can ask you, what's the difference between a network and an internet? What's the difference between a network and an internet? What's the difference between a network and an internet? So we can use internet to transmit email, voice messages, to do e-commerce, teleconferencing, the way we are doing now. We are teleconferencing through Zoom, and we have realized we have different types of network depending on geographical coverage. We studied with the personal area network, local area network, metropolitan area network, and then have wide area network. We're able also to discuss about network topologies, where we have the bus topology, have the ring topology, have the star topology, mesh topology, and advantages and disadvantages of this. So in the exam, they will ask you, by the use of a diagram, so in the exam, they can ask you, with the use of an example, with the use of with the use of a diagram, differentiate between star topology and ring topology, 10 marks. With the use of a diagram, differentiate between a star topology and a ring topology. Or they can twist the question and ask you, what are the advantages of star topology compared to ring topology? What are advantages of star topology compared to reading topology. So you should be able to have that at your fingertips. Be able to have that at your fingertips. So that's what we have been able to cover about computer networks. And these notes are available on the e-learning. So if maybe you are hearing about topologies at the first time today, it means that you are lazy, you don't know what you came to do in the university. These notes are available on the e-learning website. Also, we had a cat. There's a cat that was running. There was a cat that was running. This is just a self-assessment cat. And some of you are able to do that. Some of you are waiting for announcements from us so that you do the cat. No. I think the cat is still on. The cat is still on from my side. From my side, 500 have already done the cat. So you can do that cat at your free time just to assess your level of understanding. Then, so it means that next week we shall be covering a number system. And remember, we mentioned about decimal number system, binary number system, octal number system, and hexadecimal number system. So use this time to go through the notes on the e-learning so that next week you shall be able just to do some simple examples. As I find out the best way I can draw so that you can see what the calculations I'm doing, I will ask you to go through the last option, data representation. That's topic number 9. So that we have some videos. Your lecturer have put there some very important videos so that at your free time, know what's a binary number system. Even you try to convert from binary to decimal, or from binary to octal, or from octal to hexadecimal, so that next week we shall be winding up. So we as we agreed that next week during the class time, we shall be able to go through those number representation. Then from 5 to 6, we shall have an online card, right? So this online card for next week, we shall cover computer software. It means that next week, we just share the screen. Next week, the assessment, we shall cover computer software. We shall be able to cover data processing. We shall be able to cover data communication, right? So the cut for next week, we are going to cover 3 topics: computer software, data processing, and data communication. Then the last option, the last topic on data representation, this will be something that you will do the cut at your free time. It will be, the cut will be open. We shall not have a restriction because it involves a lot of calculations. So that's the announcement for today. So we can call it maybe a day, unless if you have any question, you can unmute or you can call. If you have any question, you can talk.
Go on. Yeah, next week,
Yes, next week from 5 to 6, we shall have a cut, but during the normal time, we shall have a lesson on data representation.
Okay, so
No, the one that's on, that is just for your own benefit. Huh? The cut that is on is for your own benefit.
What about the
But the real cut for assessment will be on Monday from 5 to 6.
Okay, sir.
Yeah.
The time is limited, sir.
Yes?
Time is limited.
No, for the next week, 1 hour is just enough. 1 hour is just enough. So the cut will be available for 1 hour, but you can only do the cut for 30 minutes. So for the latecomers, be warned. The cut will be available from 5 to 6, but you can only do the cut within 30 minutes.
Ni rahisi. Yes, Mr. McDonald, but what about the cut that was scheduled from 2nd December to 10th December?
Just that cut was meant just for practicing. It's just for practicing. The marks does not appear anywhere on your final cut mark. But the real cut, remember you did cut 1, then on Monday next week shall be doing cut 2. Cut 1 was out of 30, cut 2 also will be out of 30. So we shall be able to calculate the average so that you can get your final marks.
Bye.
Thank you. So yeah, so next week shall we have our normal class from 8 to 10. Then in the evening shall be able to have cut 2. So have a nice day. Go through the e-learning.
You too.
Through the e-learning, familiarize yourself with what we have covered so far, so that cut two will be a struggle. Cut 2 will be a struggle, so you need to read. You need to read and understand what we have covered.
What if you didn't do cut 1?
If you do not do cut 1, just do cut 2, then you shall be able to go to the lecturer yourself, because you need to explain why you did not do cut 1.
Okay. Thank you very much.